Now, we will be looking at the diagrammatic presentation. Besides the tabular form, the data may also be presented in some graphic or diagrammatic form. The transformation of data through visual methods like graphs, diagrams, maps, charts is called representation of data. It is often said a picture is worth 1,000 words. They attract a reader's attention to what they are supposed to convey about the data. Let's describe the concept, types of diagrams, and types of variables. Graphics such as maps, graphs, and diagrams are used to represent large volume of data. They are necessary if the information is presented in a tabular form or in a descriptive record. Graphical form makes it possible to easily draw visual impressions of data. The graphic method of representation of data enhances our understanding. It makes the comparison easy. It is a time-consuming task to draw inferences about whatever is being in non-graphical form. It presents characteristics in a simplified way. Besides, such methods create an imprint on mind for a longer time. This makes it easy to understand the patterns of population growth, distribution, and the density, age, sex composition, occupational structure, etc. Let's discuss about the types of data. The modern world is often described as the information age, is characterized with abundance of data. Data, however, is not homogeneous. In fact, one could talk of three levels of data: cardinal data, ordinal data, and nominal data. Cardinal data, which might be classified as interval data and ratio level data, are represented by real numbers. Example, heights, weights, prices, etc., which are quantitative or numerical that allow meaningful arithmetic operations. For example, when speaking of heights or prices, it is meaningful to talk about twice as tall or thrice as expensive, and so on. On the other hand, ordinal data are values for which only order or ranking is meaningful. For example, when rating a college course, one could use a score such as poor is equal to 1, fair is equal to 2, good is equal to 3, very good is equal to 4, excellent is equal to 5. Arithmetic operations in this case usually do not make sense. It would be awkward to say 2 into fair is equal to very good. For example, however, order is maintained no matter what numeric values are assigned to each category, and the data provide useful information in terms of ranking. For example, excellent or 5 is better than very good or 4, which is better than good or 3, and so on. Nominal data, usually qualitative or categorical data, are often arbitrary values attached to categories of interest. For example, responses to questions about marital status can be coded as single is equal to 1, married is equal to 2, divorced is equal to 3, widowed is equal to 4. Because the numbers are arbitrary, arithmetic operations do not make any sense. It is absurd to say widowed divided by 2 is equal to married. For example, categorical data, the only meaningful calculation is to count the frequency of each value of the variable. One can summarize the data in a table that presents the categories and the accounts in what is known as a frequency distribution. One can also represent the relative frequency distribution that lists the categories and the proportion with which each occurs. For cardinal data, mainly numeric or non-categorical data, several graphical methods are available. General rules for drawing graphs, diagrams, and maps. Selection of a suitable graphical method. 1. Each characteristic of the data can only be suitably represented by an appropriate graphical method. For example, to show the data related to the temperature or growth of population between different periods in time, line graphs are used. Similarly, bar diagrams are used for showing rainfall or the prediction of commodities. The population distribution, both human and livestock, or the distribution of the crop producing areas are shown by dot maps. Thus, it is necessary and important to select suitable graphical method to represent data. Second, selection of a suitable scale. Each diagram or map is drawn to a scale which is used to measure the data. The scale must cover the entire data that is to be represented. This scale should neither be too large nor too small. There are different types of diagrams. The diagrams and maps are of following types: one-dimensional diagrams such as line graph, polygraph, bar diagram, histogram, age or sex pyramid, etc. The two-dimensional diagrams such as pie diagram and rectangular diagrams. Three-dimensional diagrams such as cube and spherical diagrams. The most commonly drawn diagrams and maps are line graphs, bar diagrams, pie diagrams, flow charts and scatter plots. Let us discuss about line graph. Line graphs compare two variables. Each variable is plotted along an axis. A line graph has a vertical axis and a horizontal axis. So, for example, if you wanted to graph the height of a ball after you have thrown it, you could put time along the horizontal or x axis and height along the vertical or y axis. Each type of graph has characteristics that make it useful in certain situations. Some of the strengths of line graphs are that they are good at showing specific values of data, meaning that given one variable, the other can easily be determined. They show trends in data clearly, meaning they visibly show how one variable is affected by the other as it increases or decreases. They enable the viewer to make predictions about the results of data not yet recorded. Unfortunately, it is possible to alter the way a line graph appears to make data look a certain way. This is done by either not using consistent scales on the axis, meaning that the value in between each point along the axis may not be the same, or when comparing two graphs using different scales for each. It is important that we all be aware of how graphs can be made to look a certain way when they may not be that way. Let us take a look at an example. Here is a line graph to show the population growth in various time periods. When was the minimum population growth? Let us ask a few questions related to it. When was the minimum population growth rate? The minimum population growth was very low between 1911 and 1921. When was the highest population growth reached? The highest population growth was observed in 1971. Now let us move on to polygraph. Polygraph is a line graph in which two or more than two variables are shown on a same diagram by different lines. It helps in comparing the data. Examples which can be shown as polygraph are the growth rate of different crops like rice, wheat, pulses, etc. in one diagram. The birth rates, death rates and life expectancy in one diagram. Sex ratio in different states or countries in one diagram. Let us look at a polygraph to compare the variables. Let us discuss about bar diagram. A bar chart or bar graph is a chart with rectangular bars with lengths proportional to the values that they represent. The bars can be plotted vertically or horizontally. Bar charts are used for plotting discrete or discontinuous variables. Data which has discrete values and is not continuous. Some examples of discontinuous data include shoe size or eye color, for which you would use a bar chart. In contrast, some examples of continuous data would be height or weight. A bar chart is very useful if you are trying to record certain information, whether it is continuous or not continuous data. Bar charts also look a lot like histogram. They are often mistaken for each other. Here is an example of bar chart with country as a discrete data set. The following rules were observed while constructing a bar diagram. The width of all bars or columns is similar. All the bars should be placed on equal intervals or distance. Bars are shaded with colors or patterns to make them distinct and attractive. Three types of bar diagrams are used to represent different data sets: the simple bar diagram, the compound bar diagram, and the polybar diagram. Let's have a look at the simple bar diagram. A simple bar diagram is constructed for an immediate comparison. It is advisable to arrange the given data set in an ascending or descending order and plot the data variables accordingly. However, time series data are represented according to the sequencing of the time period. Have a look at the simple diagram. Here is a table which shows the number of trees planted by an agency. Look at another example. The data below shows the number of students present in different classes on a particular day. The bar graph for the above data is shown in the figure. Here is another example. This is the data regarding causes of accidents in factories. This figure represents the data. Now let us move on to compound bar diagram. When different components are grouped in one set of variables or different variables of one component are put together, their representation is made by a compound bar diagram. In this method, different variables are shown in a single bar with different rectangles. Look at the example of a compound bar diagram. Polybar diagrams are constructed to represent two or more than two variables for the purpose of comparison. For example, a polybar diagram may be constructed to show proportion of males and females in the total rural and urban population, or the share of canal, tube well and well irrigation in the total irrigated area in different states. Here is the example of polybar diagram. Let us now discuss about histogram. A histogram is a bar graph of a frequency distribution. Typically, the exact class limits are entered along the horizontal axis of the graph, while the numbers of observation are listed along the vertical axis. However, class midpoints instead of class limits also are used to identify the classes. The histogram describes a frequency distribution by using a series of adjacent rectangles, each of which has a length that is proportional to the frequency of the observation within the range of values it represents. Histograms are used to plot density of data and often for density estimation, estimating the probability density function of the underlying variable. There are different shapes of the histograms. Histogram comes in all kinds of shapes. Histogram is said to be symmetric if by drawing a vertical line down the center of the histogram, the two sides are identical in shape and size. A skewed histogram is one with a long tail extending to either the right or left. A unimodal histogram is one with a single peak, while a bimodal histogram is one with two peaks. Quantitative and qualitative variables. A variable is a characteristic that changes from individual to individual. For example, if someone asks, "How old are you?" then corresponding variable will be age. In this case, it is a quantitative variable, as age is some number, while in other cases it might as well be a qualitative variable like color of hair, type of car owned, and so on. Qualitative variables are usually best represented by arbitrary numbers, that is coded into nominal data. Quantitative variables, on the other hand, can be either discrete or continuous. A discrete variable takes on values of a fixed amount, example, number of children in certain household, while continuous variable can be represented by any point on a real line. Let us look at the two-dimensional diagram, that is the pie diagram. Pie diagram is another graphical method of the representation of data. It is drawn to depict the total value of the given attribute using a circle. Dividing the circle into corresponding degrees of angle then represent the subsets of the data. Hence, it is also called as divided circle diagram. The angle of each variable is calculated using the following formula. If the data is given in percentage form, the angles are calculated using this formula. A pie chart or a circle graph is a circular chart divided into sectors, illustrating proportion. In a pie chart, the arc length of each sector and consequently its central angle and area is proportional to the quantity it represents. When angles are measured with one turn as unit, then a number of percent is identified with the same number of centi-turns. Together, the sectors create a full disk. It is named for its resemblance to a pie which has been sliced. The earliest known pie chart is generally credited to William Playfair. The pie chart is perhaps the most ubiquitous statistical chart in the business world and the mass media. However, it has been criticized and some recommend avoiding it, pointing out in particular that it is difficult to compare different sections of a given pie or to compare data across different pie charts. Pie charts can be an effective way of displaying information in some cases. In particular, the intent is to compare the size of a slice with the whole pie rather than comparing the slices among them. Pie charts work particularly well when the slices represent 25 to 50% of the data, but in general, other plots such as the bar chart or the dot plot or non-graphical methods such as tables may be more adapted for representing certain information. It also shows the frequency within certain groups of information. Now, let us have a look at the flow chart or flow maps. Flow chart is a combination of graph and map. It is drawn to show the flow of commodities or people between the places of origin and destination. It is also called the dynamic map. Transport map, which shows number of passengers, vehicles, etc., is the best example of a flow chart. These charts are drawn using lines of proportional width. Many government agencies prepare flow charts or flow maps to show density of the means of transportation on different routes. The flow maps or charts are generally drawn to represent the types of data as given below. The number and frequency of the vehicles as per the direction of their movement. 2. The number of the passengers or the quantity of goods transported. What are the requirements for the preparation of a flow map? A route map depicting the desired transport routes along the connecting situation. Next, the data, a route map depicting the desired transport routes along with the connecting stations. 2. the data pertaining to the number of trains of selected routes to the flow of goods, the selection of a scale through which the data related to the quantity of passengers and goods or the number of vehicles is to be represented. Scatter plot. A scatter plot is a useful summary of a set of bivariate data, that is, two variables, usually drawn before working out a linear correlation coefficient or fitting a regression line. It gives a good visual picture of the relationship between the two variables and aids the interpretation of the correlation coefficient or regression model. Each unit contributes 1 point to the scatter plot on which points are plotted but not joined. The resulting pattern indicates the type and strength of the relationship between the two variables. A scatter plot will also show up a non-linear relationship between the two variables and whether or not there exists any outliers in the data. More information can be added to a two-dimensional scatter plot. For example, we might label points with a code to indicate the level of the third variable. If we are dealing with many variables in a data set, a way of presenting all possible scatter plots of two variables at a time is in a scatter plot matrix.